Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episode. This is the episode number 98. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The question number 1, the starting metal is 6-member cyclohexane and it have alkene inside. They ask you to guess the reagent. Product is 7-member amine there. It's a cyclic amine. So the reagent suggestions are ozone with hydrogen peroxide or methyl disulfide and SOCl2 and pyridine. Then you are using ammonia or reducing agent lithium aluminum hydride. So basically you are playing between 4 different reagents: ozone, SOCl2, amine and lithium aluminum hydride. So from the reactant to product with reagent, you might guess the question is really about reagents versus ring expansion. The answer is A. Let us see how. The answer is A. Let us see how. The starting metal you are having alkene, you have to open the ring. So you are using ozone analysis. Ozone and hydrogen peroxide. The ozone and hydrogen peroxide, what it will do is CC double bond become 2 COOH bonds. So the CC becomes COOH, you have dicarboxylic acid. Next step you are using SOCl2 in pyridine. SOCl2 is the chlorinating agent, so it converts COOH into COCl. Both become COCl. Next step you are using the amine. Chlorine leaves and the chlorine replaced by amine there. So it becomes amide. So COCl becomes CONH2. Next step you are having amine on both sides. If you have amine with carbonyl group, you might think of nucleophilic attack, which is the intra attack there. So condensation. So intra-condensation occurs between amine and carbonyl. So amine attack the carbonyl, you have new 7-member ring. So the condensation leads to the amide, which having 2 carbonyl there. Next step you are using lithium aluminum hydride, which reduces the CO bond. So reduction occurs, CO becomes CH2 there. So you have 7-member ring with amine there. So the product is clearly A, the series of reagents. Here you have to learn how you are breaking the ring and closing the ring again. So you are using variety of reagents. You have to be the master of leaving group as well as the reagent role. Then only you can achieve what you want. Then the question number 2, the starting metal is ketone, it attached with phenyl as well as propyl on the other side. You are using light, they ask you to find the product. The products can be simple benzaldehyde and alkene, or it can be a ketone, methylphenyl ketone and ethane, or it can be a benzene ring, the phenyl leaving and getting benzene, and simple butanol. Other possibility is the ring closure, the 4-member ring formation with acetophenone and alkene. So from the light and ketone, you might guess the naming reaction is involved, and ring closure is occur or not is the real question here. The answer is D. Let us see how. The starting metal you are having ketone and you are using light. So you might think of Norris type 2 reaction. Why? Because you have gamma hydrogen. In Norris type 2, the gamma hydrogen transfer to the oxygen. So you have alcohol there. After the transfer, you have diradical. Diradical can be closed in many ways. Diradical can be closed as a cyclic product. That is the possible answer. You have 4-member ring. So the diradical quenched as the 4-member ring. The another possibility is breaking of 2,3 bond. So 2,3 bond breaks. You have again 1,2 bond formation and 3,4 bond formation, which become alkene there. So you have alkene with alcohol. Next step you are having hetoenol tautomerism. So the final product can be acetophenone, alkene and 4-member cyclic ring. So the answer is clearly D. Here you have to learn 2 important things. One is Norris type 2 reaction. Norris type 2 reaction is basically the hydrogen transfer, which forms 6-member transition state, just exchange of hydrogen from carbon to oxygen. Second thing is radical quenching. Whenever you think of the reaction, you have to think many possible ways to quench the radical. Here radical is quenched by direct combination or the bond breaking as the side products. Then the question number 3. The starting metal is 6-member ring with alkene and you have conjugated cyclopropane. It attached with the ester in the side chain. You are using hydrogen and platinum. The platinum oxide reagent is special here and you are using acetic acid at room temperature. They ask you to find the product. In all the products, cyclopropyl ring is open. Whether double bond is reduced or not, side ester is reduced or not is the real question here. So from the reactant and reagent you might guess naming catalyst is involved and selective reduction occurred here. The answer is C. Let us see how. The starting metal you are having alkene, you are using hydrogen and platinum oxide. Platinum oxide is called Adams catalyst. Adams catalyst is very selective reagent. It only reduces the alkene but not any other thing. So the carbonyl in the ester will not be touched there. The reaction center is only alkene. But in conjugation you have the cyclopropane. Cyclopropane is the strained ring system which is in conjugation. So it is reduced along with the cycloalkene. So alkene is reduced along with the cyclopropane. But here is the catch. How the cyclopropane ring will open? Whether A break or B break. The A break is the major form, which is thermodynamically stable. B break is the minor one. Because the A break leads to a symmetrical addition of reagent and the product also symmetrical there. So the symmetrical reagent attack the symmetrical product. It can be simply understood by the one door is entered by two people means the crowded. Similarly, the two door can be entered by two people easily. So the answer is clearly C there. Here you have to learn two important things. One is Adams catalyst. Adams catalyst is selective for alkene, not for any other carbonyl. The second thing is if you have strained system during the reduction, it will be also reduced. Here it is cyclopropane. Then the question number 4. The starting metal is 5-member ring which have conjugated ketone and you have many hydroxy groups are there. You are using diazomethane. You have 4 different products where the all products are methylated. Whether the first oxygen is methylated or second one or third one or fourth one. The 4 possibilities given as 4 answer. So CH2N2 play the role here as a methylating reagent. So the question is simply about which alcohol is reacting here. The answer is A. Let us see how. The starting metal will contain many hydroxy groups with ketone. Here you have 4 different alcohol, but the CH2N2 is the methylating agent. It simply methylates the system, but only the acidic proton is get methylated. Here, when compared to all other alcohol, 2 alcohol in the conjugation, which can donate the hydrogen easily, it can have best acidity. So there is a possibility A and B, but A have higher acidity because of it more resonance form. If the hydrogen removed from the system, oxygen enter into the system by resonance, the double bond move to carbonyl. So you have 3 different stable system which is resonance stabilized. Similarly B is in conjugation but it will have only one resonance form, so the A hydrogen is more acidic. So if you use CH2N2, the COCH3 bond formed at A position. So among the 4 A is more acidic. Here you have to learn 2 important things. One is CH2N2. CH2N2 can play many roles. Here it is placed as methylating reagent. Second thing is methylation occur at more acidic proton. So whenever you have many hydroxy groups, you have to think of acidity whenever you are using CH2N2. Then the question number 5. The starting metal is linear system which have ester at the end and it have first carbon alkene. You are using mercuric acetate, water and THF. Next step you are using sodium borohydride and base. They ask you to find the product. The products can be simple alcohol formation, but where the alcohol is formed. Whether the alcohol is formed at first position or second position, and what happened to ester. Ester is reduced along the way or removed along the way. So from the reactant to product along with the reagent, you might ask where is the reaction center. The answer is D. Let us see how. The starting metal you are having alkene, you are using mercuric acetate. Mercuric acetate selectively to the double bond. The mercuration process is the Markovnikov of addition. What really happens is OH minus added to the more substituted carbon. So when you think of alkene, the second position OH will be attached. The other position you have mercury attachment. The mercury will be removed by NaBH₄. Again, NaBH₄ is selective to removal of mercury. So the mercury will be removed there. It is called demercuration reaction. So the demercuration occurs. You have alcohol, clean alcohol. Next step, you are using the base. So base what really do? It attacks the carbonyl, it removes the acid there. You have ester alcohol as the final product, which is D. CH3CO removed in the system, the product is D there. Here you have to learn two important things. One is mercuration and demercuration. This is an important process. It is only selected to double bond. The addition is Markovnikov addition. Second thing is sodium borohydride. It only remove the mercury there, not the carbonyl system. So it also the second selectivity in the reaction. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.